Hello, so this is question 3 of the no calculator portion of the AP exam. Alright, so we see that we have the formula. We're given the formula y equals cx to the square root 4 minus x squared. And we see that c, the constant, is equal to 6. So the first thing I'm going to do is I'm going to write this down. Alright. And I'm going to find the zeros to find the intercepts of this graph. So I can simply just, well, if I was here, I could just, I could split it up. And it's going to be here, this is x equals 0, and this is x equals 2. Well, technically plus or minus 2. However, we're only doing the first quadrant, so I'm just going to say equals to 2. So then from that, we can infer that this, this 0 is 2, this intercept where the graph touches is 2. Therefore, so now we know that this is from, this graph is from 0 to 2. And we can start writing our integral now for to find the area. So first off, we know that the lower limit is 0 and the top one is 2. And then we just take this same formula and then we put dx. All right, so now what we're gonna have to do is we're gonna solve for this. So the first thing I'm gonna do is I'm actually gonna do u substitution. So I'm gonna say u equals 4 minus x squared, and then du equals negative 2x. And then I'm going to say, that oh, I did that wrong. And since we are using u sub, we have to plug in the limits into the u, so we get a new value. So then that would make the upper limit since 4 minus x squared, and if we plug in 2 to that, it'll be 0. And then if we put the if we plug in 0, we'll get 4. And the reason why I put it flipped is that the lesser number is supposed to be at the bottom, and technically, well, this is how it would have looked like if when I just plug it in, it would have just looked like 0 and 4 normally, except you're supposed to have the smaller value at the bottom. So what I did is I used the rule where I put a negative in the front and I flipped the limits, which would make it, oh wait, that's wrong. 4 at the top limit and then 0 at the bottom limit. All right, and so then that would also be that it's going to be 6x u, and then I'm going to multiply it by that. And if we and then when we multiply this completely, what it comes out to, the x cancels out from here, and it's going to be negative 3. Okay. we can use the rule and, oh, I realized I was not. So yeah, and then we can bring this -3 to the front because it's just a number, there's no variable. So that would make it 3, like that. Therefore, we can take this part of the equation, just move this part up here. And then we can, so first I'm going to change the format a little bit. And the square root is the equivalent to the exponent 1/2. So I'm just going to say u 1/2 du. And then I'm going to find the integral. And so that if I add a, so basically what it would be is like that. For 0. So additionally, we can, since there's a 3 here and there's a 3 there, we can cross those out. It's a bad crossing out. And it would be equal to 2u 3² power 0. That's what it would be equal to because the 3's cancel out here. And so we would take that, and what it would, if when we plug in 4, it would equal to 2 4 to the 3² power minus, and then when we plug in 0, it'll just be, which is literally just equal to -0. Which makes the area, oh, oops, sorry. Which makes the area, and since the unit of this was inches and we found the area, it's going to be inches squared. All right, so I'm going to try to show the full picture of this. That is how I solved it. All right, sorry that I can't show the full thing at once. I'm balancing the phone on a mug and it's not showing the whole picture, but this is how it is. All right, so that is part A. What we're gonna do now is we're gonna move on to part B. I don't know if this is focusing or not. All right. So I'm going to look at my notes really quickly for how I solved this inside the actual exam. Okay, so cross-sectional circular slice. So I'm going to start off with what I did last time. And so the formula is y equals c of x 4 minus x squared, and this c here is a constant, so x equals 0 and x equals 2. So that's the x-intercepts. So in order to find, so it's radius, so first what I'm going to start to do, so basically I have to find the value of c through the radius of the largest cross-sectional circle. Additionally, the area of a circle, I want to know, is just for a personal, so I can better understand. So the area of a circle is equal to pi r squared. All right, and we're going to use that because the cross-sectional slices are circular. All right, so first off, so we know the upper limit. So since we're dealing with radii and what is it called? And seemingly volume, I'm going to start out by putting a pi of front of the formula. And I'm going to square it because we're looking at volume, and going back to this formula, we're looking at cross-sectionals of circles. All right, and so I'm going to put a dx here. All right. So since c is a constant, I'm actually going to bring it to the front. So it's going to be c pi 2, 0, and then 4 minus x squared dx. And so when we square this, what is it called? This function, I mean this part of the x square root 4 minus x squared, it removes the square root while also squaring the x in the front, which would make it which would, since the square root would be gone, this would be, and the x here would be squared, it would be x squared. That's how it would look like. And so then what we're gonna go from there and do is now we're gonna integrate. I mean, find the antiderivatives. So actually that makes no sense here. So what I'm gonna do first is I'm gonna distribute x squared. So it's gonna be 4x squared minus x to the 4th power dx. All right, and so what I'm gonna do now is I'm gonna use the power rule. I believe that's what it's called. And it's gonna be 4x to the 3rd power over 3 minus x to the 5th power over 5. And then it's gonna be 2, 0. And so I'm gonna move this to the side a little bit. I'm gonna say, so then when I plug it in, it'll be, so first off, what it will be is that it'll be 4 2 cubed minus 2 and since the lower limit is 0, it'll just, this part, since it's 0, when you plug it in, we'll just get 0. So I'm just gonna write, I'm just gonna say minus 0. So then we need to simplify this. Two cubed is 8, so we're gonna do over 3, and then 2 to the 5th power, I believe, is 64, but I kind of need to check, so I'm gonna do some math at the top here to check. So 2 times 2 is 4, and then times 2 is 8, and then times 2, 16, and then times 2 is 32. 1, 2, 3, 4. And one more time, it'll be 64. Yes, 2 to the 5th power is 64. So what I'm going to do is I'm going to put 64 over 5. So this is essentially what is this for again? So this is for the volume, I think. This is for the volume of the spinning toy. And in order to find the radius, what we're gonna do is we're gonna equal it to the radii, which is 1.2. And so when we solve for c, we can just divide both sides by this part. Actually, I feel like there's not enough space to do that. So what I'm going to do is I'm just going to say that C is equal to 1.2 and then pi 32 over 3, 64 over 5. So that is the value of C for this spinning toy. All right, let me show the whole problem. This is how it is. This is how I found what the value of C is for the spinning toy that has the largest cross-sectional circle slice being 1.2 inches. All right. Also, I didn't simplify the answer because it's no calculator portion. All right. Now we're gonna move on to the last part of it. Last part of this problem. I don't know why it's so zoomed in, but so we're supposed to find the volume of this. So what we're gonna do here is, in order to find the volume, first thing we have to do is we're gonna find the limits. Well, actually, when we start writing the integral to solve it, we always have to start with a pi for sure. And then, as done in the earlier ones, what I'm gonna do is I'm just gonna write how I found the limit. I mean the y-intercept. No, this is an x-intercept. So the x equals 0, which we see here, and then x equals 2, which is this part. So I'm gonna say 0 and 2. Oh, I'm not showing you. I'm gonna say 0 and 2 is the limit. All right. So what I'm gonna do is that I'm gonna use this formula. And I'm gonna square it, put dx. All right, and so what I'm gonna do is as I square it, looks like an S. When I square it, what's gonna happen is gonna be cx squared, and then this square root is gonna be removed because it's squared. So I'm just gonna say 4 minus x squared dx, and then since this is a constant, what I'm gonna do, c is a constant, I'm gonna bring it up front, so it'll be c pi 2 0 x squared 4 minus x squared dx, which is gonna be equals to c pi 2 of 0, and I'm gonna distribute, so it'll be 4x squared minus x to the 4th power dx. So now what I'm gonna do is I'm gonna integrate it, and so this is just wrong one. Then we're gonna put we're gonna use the power rule. We're gonna add 1 to the exponent, and with that new exponent we're gonna put it at the denominator. So we're gonna do, I should say 2 0, that. All right, so I already know when I plug in 0, I'm just gonna get 0. So I'm not gonna bother plugging that in. And what I'm gonna do instead is I'm gonna say, I'm gonna put it there like that. Say this is gonna be c pi, and then what am I doing? Then I'm gonna plug in 2 into it, so it's gonna be cubed minus 2 to the 5th power 3 5, and when we simplify that, it'll just be 64 over 5, just like the previous problem. So what we're gonna do now is, in order to find c, so if this finds the volume, if this is the volume, and the volume is equal to 2 pi, so what I'm gonna do is I'm gonna do 2 pi equals c pi, and 32 over 3 minus 64 over 5. And so what I'm going to do is I'm going to divide this side by pi. I'm going to divide that side by pi. Oh, I wrote that wrong. And so what's going to happen is that the pi is going to get removed from both sides. It's going to be equal to 2 c, and then minus 64 over 5, which means that we can just simply find c by dividing this by both sides. So it'll be 2 over 32 over 3 minus 64 over 5. All right. Oh, I wasn't showing it. All right, so that's how I got c. Basically, I moved the pi from both sides. So this equals to the volume after I integrated. I made it equal to 2 pi because that's what they told us what the volume was. And so when I did that, I divided pi by both sides and removed it. And then I isolated c, which gave me this answer, which I believe is the value for this spinning toy. I'll write an arrow. Okay, so I'm going to show the whole problem. So that's how it is, the volume. And then after we found the volume here, I made it equal to 2 pi because that's what the problem said. And then I solved for C. Okay. So that looks like that's the end of question number 3, I believe. Yes, it is. All right. Thank you.